shear design will find nominal shear capacity and also tau c based on percentage steel and grade of concrete and tau c max based on grade of concrete. Our tau v should be less than or equal to tau c max. Then case 1 is where our tau v will be less than tau c. Then no shear reinforcement is required. But clause 26.5.1.6 of IS 456-2000 recommends a minimum shear reinforcement based on ASV by B into SV should be greater than or equal to 0.4 by 0.87 Fi, in which ASV is area of shear reinforcement and SV is spacing of shear reinforcement. Spacing of shear reinforcement, that is stirrups in mm. Whereas the second case 2 is where our tau v will be greater than tau c, then shear resisted by concrete will be shear stress in concrete into concrete area, that is tau c into b into d. Then shear to be resisted by reinforcement shear reinforcement, that is stirrups, will be VUS. VUS is calculated as VU minus tau c BD. Now when vertical stirrups are used, then VUS will be equal to VUS will be equal to 0.87 Fy ASV into D by SV, where SV is spacing and ASV is area of stirrups provided. Whereas when inclined stirrups are used, VUS will be equal to 0.87 Fy ASV into D by SV into sin alpha plus cos alpha, where alpha is angle of inclined stirrup with the axis of the beam. This alpha value should not be less than 45 degrees. This vertical stirrups formula can be understood in this format, where this is our beam section and if this is our longitudinal reinforcement, then our transverse reinforcement, that is vertical stirrups, are in this format. Then let us consider a part in which this is our spacing SV, then this will be SV by 2 and this part also SV by 2. So our considered section is like this, having SV by 2 and SV by 2 on both sides. This total will be SV, and our reinforcement, that is stirrup, is here in the middle. Then shear resisted by this reinforcement, or the horizontal shear resisted, will be 0.87 Fy is its capacity into ASV is the area of this reinforcement provided, that is stirrup provided, by it is provided in a spacing of SV, then the horizontal shear actually coming will be, this is the horizontal shear resisted, and the vertical shear resisted by vertical stirrup. Whereas the vertical shear coming onto the beam will be equal to VUS by the total depth is D. So VUS by D, then equating this, VUS by D is equal to 0.87 Fy into ASV by SV. From this, VUS will be equal to 0.87 Fy ASV into D by SV. So this is the formula for vertical stirrups. And whereas if bent up bars are used, case C we can consider as bent up bars, a single bent up bar, or a group of parallel bars, then VUS is given as 0.87 Fy into ASV into sine alpha. When bent up bars are present, when bent up bars are provided, then their contribution towards shear resistance shall not be more than 50%, more than half, that is 50% of the total shear resistance. As given by IS 456 2000.